Good morning, class. We are looking at Chapter 1, Sequences, Section 1.6, Sequences and Difference Equation. We are finishing it up, the second part. Here's an example. Pacific salmon. Just move this. A quick second, everybody. Pacific salmon populations have discrete breeding cycle in which they return from the ocean to streams to reproduce and then die. This occurs every 1 to 5 years, depending on the species. Part A. Suppose that each fish must first survive predation by bears while swimming upstream, and predation occurs with probability D. After swimming upstream, each fish produces B offsprings before dying. The stream is then stocked with M additional newly hatched fish before all fish then swim out to sea. What is the discrete time recursion for the population dynamics, assuming there is no mortality while at sea? You should count the population immediately before the upstream journey. The second one, part B, suppose we have a situation slightly different. Suppose that instead of preying on fish while they swim upstream, bears do so only while the fish are swimming downstream. What is the discrete time recursion for the population dynamics? Again, assume there is no mortality while at sea. And finally, part C, which of the recursions obtained in parts A and B predict the largest increase in population size from 1 year to the next? Justify your answer mathematically, and in terms of biology, you can assume D is between 0 and 1 and B is larger than 0. D is the proportion, the probability, and the probability is always between 0 and 1. Can be 0, can be 1, but can't be negative or larger than 1. So for this one, we're going to go between 0 and 1. So let's look at this concept, very simply put. The first part. So here's the question that was discussed. Number of fish. How many do we have to begin with? We don't know. X, Y, Z. Let's call it N sub T. Predation with the probability of D. So the very first thing that happens, predation occurs with the probability of D. That means, for example, these, let's say 10%. That means 10% will be gone. If it's so, that means 90% remains. Okay, so we got to call it N sub P, which means N sub T minus D times N sub T, or simply put, understand why it's 1 minus D times N sub T. Again, you can give it a number. Assume it happens with 20%, so that means 1 minus that, 80% is left. The next step, when they get up there, they give us B offsprings before dying. So simply put, multiply this one by B. That's all. Or you can say this one plus B times this one, and then minus this one, because they all die. Okay, so same amount, then add to it B times N sub P minus N sub P, or just simply put multiply the previous step by B, because each one gives us B offsprings. Finally, we add how many? M. So to this number, add M. That's the final answer with part A. What happens in part B? We have a slightly different situation. Again, the same number, X, Y, Z, in this case, N sub T. So that's the number of fish at time T, just like before. Each fish produces B offspring. So first they produce B offspring, so B times that number. The stream is then stocked with M additional newly hatched fish. So we add M. Now, at the last step, predation happens. That means a percentage is gone. Let's say 10% is gone, 90% remains. So 1 minus D times this remains. This is easier to follow that way. So the question is, which one is producing more fish for us? Well, what do you think? Depends on how you look at that if you want to discuss the biology, but we can prove it mathematically. Okay. As far as biology is concerned, one can argue for each side. As far as math is concerned, you just look at the difference between the two. If part A minus part B is positive, then A give us more. If it's negative, then B gives us more. So let's do part A minus part B. So part A is this, part B is this. So if you multiply B by 1 by n sub t, and then B by minus D by n sub t, and plus m, you get this one. So B n sub t minus BD n sub t plus m. And this one, 1. Okay, so 1 times B n sub t is B n sub t. 1 times m is m minus dB or BD n sub t and minus dm or md. So we are distributing everybody. We are going to negate everything. So this part remains unchanged. This becomes negative. This becomes negative. This becomes positive. This becomes positive. These two cancel each other. These two cancel each other. These two cancel each other. We are left with MD. And MD is positive because M was a positive number of fish we added, and D is the percentage. It's a probability, it's positive. Because it's positive, that means the first one gives us more, part A. And it makes sense. Part A, all additional fish survive. Remember, we add M at the end. But in part B, all fish, including the ones we added, face predation. That's why.